Okay, we're going to finish off this, still dealing with compound interest formula, but doing a little more fancy work with our I and our N values. So before we can move into that, we need to define a few things just in case you're not sure. So if something is compounded annually, that means once a year. Semi-annual is twice a year. Quarterly means 4 times. Monthly means 12 times. Weekly, 52 times. Daily, 365 times. Okay, so when we're doing these questions, we just have to adjust our I and our N values. So I is going to be our interest rate divided by our compounding periods. Okay, so if we're getting interest monthly, then we have to take that interest rate and divide it by 12, for example. And N, our compounding periods, instead of it being because sometimes you'll get interest compounded monthly. So that means if I had a year, I'm going to actually get interest 12 times because it'd be our number of years multiplied by the compounding period. So if I get it semi-annually for 3 years, that would mean 3 times 2, I would get interest 6 times. Okay, so let's look at this first example. So these are just kind of using that idea. So Kevin wants to invest the money he earned in piano lessons. He found an online bank that has a high interest e-savings account rate of 1.8% per year, and it's compounded monthly. So if it was, what would be the annual interest rate then? So I'm going to take, or sorry, what would be the monthly interest rate? So that 1.8% is for a whole year, right? So if I want to figure out how much it is for a month, I would divide by 12, which would give me 0.15%. And then if I wanted to put that into the formula, I would still need to write that as divided by 100. So if I'm putting it into the formula, I would put in 0.0015. So you just have to watch because you're going to get some fairly lengthy decimal numbers. And then how often will the money be compounded in 5 years? So if it's getting compounded monthly, so I would have 5 years times 12 times in a year would give me 60 times that the bank would give me interest, okay? So usually this is how you can kind of rack up some more money. Okay, let's do an example using the formula. So Cheryl manages a high-rise building in Vancouver. She's earned $40,000 in condo fees and wants to invest them. So she's going to split her investment. She's going to invest $20,000 into an account that pays 1.8% per year, compounded semi-annually. And then she's going to take the other $20,000 into an account that has the same interest rate, but it's going to be compounded daily. We want to figure out which one's going to earn more money. Okay, so we're going to do 2 calculations here. So number 1, A, P, I, N. So the principal, the amount invested is 20,000. Your interest rate is 1.8% per year, compounded semi-annually. So you've got to go 1.8 divided by 2, which is going to be 0.9, and then you're going to divide that by 100. So 0.009, and N is going to be 3 years. Semi-annually is twice a year, so that's going to be 6. So then I substitute it into my formula. So I've got 20,000, 1 plus 0.009 to the power of 6. Okay, so put that in your calculator, you get $21,104.59. So that is the first one where I get interest semi-annually. Now let's take a look if I get interest daily. Okay, my principal is again going to be 20,000. My interest rate this time is going to be 1.8 divided by 365. And then I'm going to take that divided by 100. So what I'm going to actually do here is if I take, so it doesn't matter what order I do these in, I'm going to take the 1.8 and divide it by 100. So I'm going to get 0.018 over 365. And I'll just, that's an ugly decimal number, so I'll just keep that. And then 3 years daily, you're going to get interest 1,095 times. So the numbers are a little uglier here, but that's okay. We've got calculators. 20,000 times 1 plus 0.018 over 365 to the power of 1,095. Now, when you go to do this in your calculator, I think you're probably going to have to do the bracket part first. So what I would do is I would take the 0.018 divided by 365 in your calculator, get a number, then add 1. Okay, so you're going to have 1 point something. And then take that number and then do your exponent, 1095, and then take that answer and multiply it by 20,000. Okay, you may be able to just use your calculator and plug it right in, but you'll have to test that out and see. You should get 21109.66. So we can see that we do get a little bit more money by getting the daily interest. We're getting $5 extra or something. So we want to choose number 2. Okay. One last thing before we move on here. So we're going to talk about it's called the rule of 72. So basically what this does is it helps us to determine how long it's going to take our money to double. Because sometimes you're like, oh, I want to invest money, but how long will it take it to double? So the rule of 72 says that the years that it'll take to double is going to be 72 divided by your annual interest rate. Okay, so if James invests $3,000 at 3.6% per year compounded annually, how long will it take the money to double? Okay, so the doubling is going to be 72 divided by your annual interest rate, which is 3.6. So when I do that, I get 20. So it's going to take about 20 years to double. In B, it says to use the compound interest formula to calculate if it is reasonable. Okay, so what we're going to do is we're going to leave the amount unknown, and we're going to put in $3,000 at an interest rate of 3.6%. So when I divide that by 100, I get 0.036. And we're going to say 20 years, and we'll see if we get it to double on us. So A is equal to 3,000 times 1 plus 0.036 to the power of 20. And when I do that, I get $6,085.78. So we can see that that is slightly more than double. He started with 3,000 and he ends up with a little over 6,000. So it is a good prediction that in 20 years, my value will be double. Okay, so that is called the rule of 72. Okay, you can go ahead and practice some questions now.